the combination of all the truth values. Finally, in the last column, you are getting false, true, false, true, false, true, false, true. So what does P disjunction Q implies? It implies if two statements are false, then only it is false. In all the other cases, it is true. So we have a disjunction here. So what does the disjunction says? Disjunction is false when both are false. In all the other cases, it is true. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we will be studying about the converse, inverse and contrapositive of a given statement. What do you mean by this converse, inverse and contrapositive of given statement? How to write it? So this is possible when the statements are given in the form of a conditional. Conditional means if-then statements. For example, we have a conditional statement P implies Q. Then how to write the converse of the given condition? The converse of the given conditional is Q implies P. Take it as an example. If I work hard, then I'll get a good marks. So how to write the converse of this? That is, I'll get good marks if I work hard, like this. So converting or reversing the statements. So if the conditional is in the form of P implies Q, then we write it as Q implies P. Next we come across the conditional not P implies not Q. So P must be changed to not P and Q must be changed to not Q. For example, if all sides are equal, then the quadrilateral is a square. We can say if all sides are equal, then the quadrilateral is a square. If you convert this in the form of inverse, if all sides are not equal, then the quadrilateral is not a square. So you are just writing the negation of both P and Q. That is the inverse. Next we will take the conditional not Q implies not P. That is the inverse. The converse of the inverse is nothing but contrapositive. If you have a statement like if all the sides are not equal, then the quadrilateral is not a square. Then reverse the statement. The quadrilateral is not a square if all sides are not equal. So negating the statement and vice versa it is nothing but the contrapositive. Let's solve out few proposition or conditional statement in the form of converse, inverse and contrapositive. Write the converse, inverse and contrapositive of the following. If I work hard, then I get the grade. So how to write the converse? I am writing the converse part here. So converse says, so if this is P implies Q, then what is converse? Q implies P. That is, I get the grade if I work hard. So this is the converse of the given statement. So let's see the inverse part now. So inverse part, inverse is nothing but not P implies not Q. Take the negation of two statements. If I work hard, if I do not work hard. So if I do not work hard, then I do not get the grade. So this is the inverse. Contrapositive is reverse of the inverse statement. So contrapositive is not Q implies not P. So what is not Q? I do not get the grade. I do not get the grade if I do not work hard. So this is the contrapositive of the given statement. Remember, so converse is the reverse of P implies Q. That is Q implies P. inverse is not P implies not Q, and contrapositive is not Q implies not P. So all are conditional statement in different cases. So let's see the next problem. If x is less than 1, then it is a prime number. So let's write the converse of this. So x is less than 1 is P. It is a prime number is Q. So what is the reverse? Q implies P. So x is a prime number. X is a prime number if it is less than 1. The sentence should start with x only, then only it becomes it later. So therefore here also I will start with x, then I have converted it to it in the second statement. Next I will take inverse. Inverse is not P implies not Q. So what is not P? If x is not less than 1. If x is not less than 1, then it is not a prime number. So this is the inverse. Let's write the contrapositive. So contrapositive is the converse of the statement. That is, x is not a prime number. X is not a prime number if it is not less than 1. So not Q implies not P. So this is all the three statement of the given statement. Next question. If the questions are easy, then students score better marks. So the questions are easy can be considered as P. Students score better marks can be considered as Q. Now converse. Converse is Q implies P. So first Q then P. So the students score better marks if the questions are easy. If the questions are easy. So this is the converse. Inverse is not P, not Q. So you should imply not for the statement. If the questions are not easy, if the questions are not easy, then students do not score better marks. So this is the inverse statement. Now contrapositive is vice versa of the inverse. So contrapositive here, it becomes students do not score better marks if the questions are not easy. So this is the contrapositive of the given statement. Let's look at one more example. If x square is equal to y square, then x is equal to y. So let's write the converse. What is converse? If x is equal to y, then x square is equal to y square. Inverse, simple, apply not. Not means if x square is not equal to y square, then x is not equal to y. Similarly, contrapositive, that is, if x is not equal to y, then x square not equal to y square. So these are the ways to write the converse, inverse and contrapositive of any conditional statement. Next we have construct the truth table for the following. So here one proposition is given. We need to write the truth tables for all the following. So how to write the truth table? So here I have three terms. So let me take P as true, 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 false, 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 false. So what are the possibilities of P? And 4 times true, 4 times. And Q I will take it as true, true, false, false, true, true, false, false. Next we will take for R. R we will take it as true, false, true, false, true, false, true, false. First let us solve this. Before that, let's see what is not R. So R is this. What is not R? If it is true, that is negation of R. If it is true, then it is false, false, true, true, false, false, true, true, false, false, true, true, false, false, true. So this is the negation of R. Let's take Q with negation of R. Here we have disjunction. What does the disjunction statement says? It is false when both the conditions are false. So after writing the negation R, let's solve this proportion now. So it is a conjunction of Q and negation R. What does the conjunction statement says? It is true when all the two statements are true. So find the cases where both the statements are true. So we have Q and negation R. So we have true, false, hence it is false. We have true, true, so it is true. Third is both are false. Fourth is false, true, so it is false. Next is true, false, false. Next is true, true, so therefore it is true. Next is false, false, so false. Next is false, true, so therefore it is false. So we have only two truth values of true and rest of the things are false. Next is, let's take the complete statement. So we have a disjunction here. What does the disjunction says? Disjunction says it is false when both the statements are false. Let's take this one and this one now. So this will be false when both the conditions are false. In all the other cases it is true. Find the case where both the conditions are false. So false, first one. Next we have the third one, false. Next we have the fourth one as false. Next we have the fifth one as false. In all the cases it is true, 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 true. So here we have found the answer for the given proposition. So whenever the combinations of all the connectives are given in one proportion, we have to write it in the form of a table and write their truth values. So this is where we can analyze whether the given statement is tautology or contradiction. What do you mean by this tautology or contradiction? Let's see now. So we have a statement called tautology or a contradiction. What do you mean by this tautology? So look at the definition 1 now. A compound proposition is said to be a tautology if all the truth values of the truth table, that is the combination of those truth values, will be true always. So previously you can see here the combination of all the truth values. Finally in the last column you are getting false, true, false, true, false, true, false, true. For a tautology, the last column must be true for all values. Then only we say it is a tautology. Next we say a contradiction. Look at definition 2 here. A compound proposition is said to be contradiction if it is false for all the possible truth values of its component. Again in the previous example you can see you have false, true, false, true, false, true, false, true. But if the column shows all the truth values as false, then we say it as a contradiction. If it is, in this case, it is neither tautology nor a contradiction. If all the truth values of its components are true, then it is tautology. If all the truth values of its components are false, then it is a contradiction. If it is a mixture of the truth value of the truthfulness and falsity, that is T and F, then it is neither tautology nor a contradiction. So for your examination purpose, proving tautology, contradiction, and next like logical connectivities, like verifying and writing the truth table carries 5 marks in your examination. So these questions are very important for 5 marks. Now let's see now. So the given compound proposition is given in the form of a statement. Let's check it all. So we have a combination of P and Q here. I have already drawn a table which you have to do it later. So now let's write the truth value. When you have P, Q, R, you write the values as I have written previously. But here you have only 2 components. So write the values as true, true, false, false. And here it is true, false, true, false. These are the only possibilities when you have only 2 components, that is P and Q. Now next, here what is required? See here we need a negation of Q as well as negation of P. So therefore, first let us solve the first statement. For that I need negation Q. What is negation Q? That is if it is true, false. If it is false, it is true. So again, false, true. Next here, so this is a conjunction statement. What does the conjunction statement says? If both the statements are true, it is true. In all other cases, it is false. So find both the cases, that is P conjunction, that is P and not Q. Find the case where both the cases are true. So only in the second one. So it is true. In all the other cases, it is false. So next one, let's check it for negation of P. So negation of P is true, true, false, false. So this becomes false, false, true, true. So next you can look here, negation P, disjunction Q. What does the disjunction statement says? If both the statements are false, then only it is false. In all the other cases, it is true. So let's find the negation P. So this is negation P, disjunction Q. So this one. So combine this, where both the statements are false. It is false, true. So therefore it is true. Again false, false. It is false. Next case you see, negation is true. Q is true. So therefore it is true. So next case, negation is true. Q is false. Therefore it is true. It is false only when 2 cases are also false. Next we will take the conjunction. So look here, the conjunction. So I have taken this as statement A and this as statement B. I am combining these two, A and B. So when is A and B are true? When both are true. In all the other cases, it is false. So in the first case, it is false and true. So therefore it is false. In the second case, true, false, false. In the third case, it is false, true, false. In the fourth case, it is false and true, it is false. So look at the last column, you are getting the statement for all the truth values, it is false. So therefore, is it a contradiction or not? Yes, it is a contradiction. So yes, you are going to write, yes, it is a contradiction. Like this, you have to verify the truth table for each propositions. Let's look at the next question. We have P, Q, and according to the question, I have divided the columns. So let's write the values. True, true, false, false. Next Q, true, false, true, false. In the question, I need not P. So not P is false, false, true, true. Let's take the combination of not P and disjunction Q. Disjunction will be false if the two statements are false. So therefore, only for this case it is false. In all the other cases, the value is true. Next, we have an indication. What does the indication implies? If you have P implies Q, if P is true, Q is false, then it is false. In all the other cases, it is true. So let's find the statement here. P is true, Q is true. So therefore this is true. Next we have P is true, Q is false. So it is false. Next we have P false, Q true, it is true. Next we have P false, Q true, it is true. So what do you think? Is the given contradiction or a tautology? So it is neither a tautology nor a contradiction because you have a mixture of both false and true. Next question. So we have only P and Q. So let's write the truth values. True, true, false, false. Next, true, false, true, false. So observe the question, we need not Q, not P also. So let's solve this bracket first. We have P disjunction Q. So what does P disjunction Q implies? It implies if two statements are false, then only it is false. In all the other cases, it is true. So both the statements are false, it is false. In all the other cases, it is true. Next we'll write not P. Not P is false, false, true, true. Next again we have a conjunction of not P and these two columns. So what does the conjunction says? If both the statements are true, then it is true. In all the other cases, it is false. So therefore both the statements are true only here. In all the other cases, it is false. Next we have a combination implication with Q. So this with Q now. So what is the statement with? This must be true, this must be false. This column, wherever you find true, along with that if you find Q as false, then only the given statement is false, otherwise it is true. So implication will become false if P is true, Q is false. So first one is F. So first P only is F, so I can write it as true and here it is true. Next check, P is true, find Q. Q is also true, so therefore I cannot write false, so it is true. Next, P is false, Q is false, it is true. So you can see the last column, by the last column we can say the given proposition is a tautology. Since all the truth values are true, it is a tautology. Next one, we'll take one more. Negation of P implies negation Q and negation P double implication Q. So let's write the truth values. True, true, false, false, true, false, true, false. Negation Q is false, true, false, true. Why negation Q? Because let's solve the bracket first. In that I need negation Q. Then we will take P implies negation Q. Now P implies negation Q. P must be true, Q must be false. In all the other cases, it is true. So let's find P is true, Q is false, it is false. In all the other cases, it is true. Next, we have outside, the negation of this one. So the negation of this one is true, false, false, false. Let's come to the second statement. We have negation P. Negation P is false, false, true, true. So negation P, biconditional Q. What does the biconditional says? Biconditional implies both have same truth values. So it is true when both have same truth values. In all the other cases, it is false. Now let's check the negation P along with Q. So first one is true, false. So it is false. Second one is false, false. So it is true. Both are having same truth values. True, true, true. Next, false, true. It is false. Now let's combine these two. So we have a disjunction here. So what does the disjunction says? Disjunction is false when both are false. In all the other cases, it is true. So let's see now. So this is true, 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 false. So we have only false, false at the last. So therefore it is false. In all the other cases, it is true. So therefore, what we can observe in the last column? It is true, true, true and false. So therefore it is neither a contradiction nor a tautology. Let's take one more question. We have negation of P disjunction Q implies negation P conjunction negation Q, or disjunction can be read as or. Negation of P or Q implies negation P and negation Q. So let's write the truth values of P. True, true, false, false. Let's Q, true, false, true, false. Let's take P or Q. So P or Q is false when both are false. In all the other cases, it is true. So true, 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 false. Next, the negation of this will be false, 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 true. Next, we'll take negation of P. So false, false, true, true. Negation of Q is false, true, false, true. Next, we will take the conjunction of negation P and negation Q. So, and is true when both are true. So, find the cases where both are true. The last case. In all the other cases, it is false. Now, let's take the implication of these two. So, what is the implication? Here I need true. Here I need false. Then only it is false. In all the other cases, it is true. So, for the first one, it is true. And for the second one, it is true. For the third one, it is true. For the fourth one, it is true. So we have got all the values of the last column as true. So therefore, the given proposition is a tautology. So in today's section, we have learned how to write the converse, inverse and contrapositive of a given conditional statement, as well as to prove whether the given proposition is a tautology or a contradiction. From this session, you may get 5 plus 2 marks, that is 7 marks for your examination. Writing converse, inverse, contrapositive question may carries 2 marks, and tautology, contradiction question may carries 5 marks. We'll meet you in the next question with the new concepts of mathematical logic. Until then, keep watching, keep learning and keep exploring. Thank you.